a parametric equation. The second one is finding a particular coordinate at any given t. So that would be, where is the object at the start? So you plug t equals 0 in, or where is it at the end? You plug in t equals 5, things like that. And the major one, the one that's probably going to involve the most working, is eliminating the parameter t. That basically means take the parametric equation and turn it into y equals 2x squared plus 1, or x squared plus y squared equals 9, right? Get rid of the t's and rewrite it in terms of just x's and y's. So if you've started this homework, this will make sense because you know that you've probably been asked all 3 questions. So let's have a t squared take away 2t, no, bad choice. T squared plus 1, much better choice. And y equals t squared plus 2t plus 1. So we are going to do a parametric equation of this format. Now, the thing that's going to make this easy is the same thing that made polar easy. Can you remember that we had a piece of software that basically let you graph polar equations without you really doing too much effort? Remember that guy? Well, there's another function that does parametric the same way. So I'll just remind you where it is. If we go in here, and I go here, and I go here. Right, I don't know, can you see a Canvas home screen right now?
Yes.
Okay, so do you notice that the guy here, it says parametric equation grapher? You see this one here?
Yeah.
Right, that's the one you're going to click for these guys here. And if you hit this little button here, it gives you a bigger version of it. So you basically type in the information that you need. So in this case, it's t squared plus 1. And this fella here is the y. And the question I wrote down was t squared plus 2t plus 1. So t caret, that's t squared, plus 2t plus 1. Now, some questions give you a start and finish. Sometimes it's 0 to 5. Sometimes it's -6 to 6 or 0 to 2 pi, whatever it may be. Can we pretend that this question was -2 to 2? Right? Now, if you take, excuse me, if you take this check mark, what you're looking at is where the object is right now. And can you see at t equals -2, its coordinates are 5, -2. Now, as I move this slider, try to move this slider, do you see that I make the curve harm? Now, I'm going to try and draw a vague version of what that looked like. Did you notice that this curve has a direction to it? You start off at 5, 1, and then as the values of t increase up to 0, you're about here, and then 1, and then finally 2, right? So, if you were given a question, one of the pictures would look something like this guy, right? And then there'd be 3 other guys that don't look like this guy. But you might get, and I hope they do this, you might get a question where it's the same graph, but what we call the orientation is different. Remember the one we drew went this way? In this case, you finish there. So if that was your choice, wouldn't you pick the top graph, not the bottom graph? Because they both look the same apart from orientation. So are we comfortable with, you plug X equals, you plug Y equals, you see a picture, and then you go and you look at the 4 choices and you pick the pictures the same as yours. That makes sense? Just kind of like 8-2. Was 8-2 should have been pretty quick, wasn't it? You just plug it in, you look at the picture, it's B. Plug another one in, it's A. Right? Think of it just like that, right? But with parametric. Now, that's phase 1, right? Draw the picture thing. That's how that works. Now, the second question. Suppose we ask you to find out where it is at t equals 0. Well, the x coordinate is 0 squared plus 1, which is 1. And the y coordinate is 0 squared plus 2 lots of 0 plus 1, which is 1. So at t equals 0, you're at the point 1, 1. Pretty obvious what to do in these types of questions. And maybe they'll say, where is it when t equals 2? Right? That might be the second version of this question. The x then is 2 squared, t squared plus 1, that's 5. The y is t squared, so that's 2 squared, 2 lots of 2 plus 1, which I believe is 9. So your answer in this case would be 5, 9. And as long as you have a formula for x and y using t, if I tell you the t, isn't it kind of plug and chug? Right, you plug in the t, you evaluate it, you plug in the t, you evaluate it. One gives you the x coordinate, the other one gives you the y coordinate. Bingo, you got your guy. That seemed pretty much straightforward.
Just plugging numbers in.
Plugging numbers in, that's pretty much it. So let's look at the third stage. I'm going to rewrite the equation because it's kind of out of sight now. Now, in this situation, you're being asked to eliminate the t, which really means you're being asked to find a formula for x's and y's, right? A single formula connecting x's and y's together. And the trick to doing this is, is substitution. So what I want you to do is choose one of the two, can be either x or y, that you can convert easily into t equals. Right, so I'm looking at the two equations. X equals t squared plus 1, and the other one is y equals t squared plus 2t plus 1. One of those equations I can turn into a t equals without too much trouble. And the other, I don't even want to go near, right? Which one of those two is the easiest to convert?
Well, of course, it'd be x.
I would agree. Normally, try and do the x if you have a choice, because sometimes both of them can be done, right? You can do it with the x's, you could do it with the y's, but if that's the choice, pick x. So in this case, I'm going to start off with that fella. That's now going to become that guy. And then I am going to do something to both sides to get t equals. What will I do to both sides to get t equals?
Square root.
And normally when you do that, don't you give a plus and minus to both? I'm going to make the assumption, because I have to or else it just gets weird, I'm going to make the assumption that t is positive, because we don't want going back in time kind of questions, right? So that's my argument for that. Now, once you've got this, you then do the substitution. That's what y is. Replace the t by the square root of x minus 1. And sometimes, if you're really lucky, you'll be finished. And other times, you have to make it look prettier. I call it style points. Would you agree that this equation could be made a little bit prettier than it is? In particular, can't I replace the square root of x minus 1 all squared by something nicer than that? Essentially, they cancel each other out. So you get that. Which I would suggest is much nicer answer. Agreed? And then I said, oh, I just noticed something. Don't the ones cancel out? And once you've done the best you possibly can, that's your final answer. So this parametric equation is the equivalent to this Cartesian equation, right? X's and Y's. As a process goes, does that seem algebraically a sensible way to do this question, right? Pick one of the two equations and make it a t, and then substitute that into the other equation, then make it look pretty. Good. Right, let's move on and try a different question. Suppose we have well, forget about sketching it. That's just plug it into the the software and look at the picture. I'll do one example of the thing. Let's find out where it is when t equals 0. Right? Suppose the question was, where would it be at the beginning? Then won't the x be 2 lots of nothing, add 1, nothing, nothing, take away 1. At t equals 0, it would be at position 1, comma, negative 1. Right, let's focus on the substitution stage. And I'm going to show you a little shortcut that you can sometimes do. But the first time, I'm not going to do the shortcut. I'm going to go the usual typical way of doing this. One of these equations you can turn into t equals, and the other you probably can't, right? Would you agree it's x equals is the guide to use? Can you pretend a question where they switch places, where this was x and this is y? Because that will happen, and in my next question I think I'll do that. What that will mean is that when you're finished, your equation won't be y equals x squared plus 1. It'll be x equals y squared plus 1, right? It'll kind of look back to front. And that can happen. In this case here, I'll subtract 1 from both sides. So as long as you do it to both sides, it's okay rule. That's what I call that. So what am I going to do to both sides next?
Divide by 2.
And I'm going to call the left-hand side, when you divide it by 2, I'm going to call it a half x take away a half. Right, it's the same thing as dividing by 2. Now, to get t, don't you just take the square root of both sides? Agree? Now, y is going to be t to the 4th, the square root of a half x take away a half to the power of 4, plus 4 lots of a half x take away a half, all squared, take away 1. Not even in a good day would I consider that the end of the question, right? You know you must be able to do nicer things to it, right? Of course, it's not easy, but if you look really carefully, if you take a square root and you raise it to the power of 4, doesn't the square root get killed off? You don't get a half x minus a half. You get a little bit more than that, don't you? Because won't a square root, which is basically a half power, raised to the power of 4, won't that get you a half x minus a half squared? Does that make sense? A square root raised to the power of 4 gets you a thing squared. On the other hand, what will the square root of x minus a half all squared get you? Well, don't they essentially just cancel out and you get that? Take away 1. Now, do you think that's going to be considered the best version of this answer? Or will we keep going?
Just a little bit more.
Just a little bit more, okay. You're going to trust me on this. If you FOIL this guy out, you get 1/4 x squared. Take away a half x plus 1/4. 4 times this guy gets you 2x. 4 times this guy gets you -2, take away 1. And then if you collect like terms, that and that gets you 3/2. And that gets you what I think -3/4. So basically, don't you just get an ugly quadratic? Agreed. Now, that is totally valid. It works fine, not a problem. I'm going to show you a shortcut. So we're starting off with the same 2 equations, but I'm going to get to the answer a little bit easier, just a little bit. Okay. So x minus 1 is 2t squared, and a half x minus a half is still t squared. I haven't done anything new. The only difference is I'm going to stop there. When you look at this, do you see that t squared is a half x take away a half? Wait a minute. Isn't 4t squared then 4 lots of a half x minus a half? And isn't t to the 4 just t squared being squared? So that gets me 1/2 x take away a half squared, which is basically, it takes us to this line here. So do you see that, well, I mean, I'm skipping the rest because it's the same working from that point onwards. But can you see that that reduced my workload a little bit? Now, I skipped a couple of lines of working, which is always good, if you can see it. Now, if you didn't see that, can't you still fight your way through this and it works? It's not like you need to know the shortcut, but if you see it, it can make your life easy. Okay, let's switch places. What do I mean by that? Right, let's suppose we are being asked to eliminate the t, which is basically the third thing that you're typically asked to do. Would you agree that you're going to have problems taking the x equals equation and rewriting that as t equals something? Typically, if there's more than one t, it's not the guy you're going to use. On the other hand, would you agree this guy here works pretty well? And I'm going to change this question just because I wanted to put a half t plus 4. Well, let's focus on this one. Take away 4 from both sides. I actually get an added benefit by doing this. What will I do to both sides to find t?
Multiply by 2.
So you get that. Looking good? Now, that makes x equals 2y take away 8 cubed plus 2y take away 8 plus 7. And you're just going to trust me on the next bit. You normally won't get anything as bad as cubed, to be honest. I think the worst they ever do is squared. But just to show you what you would need to do if you've got a cubed. Do you know you'd have to take 2y minus 8 times 2y minus 8 times 2y minus 8, right? So you're just going to trust me when I write down what that is. Agreed? Because we don't want to spend 20 minutes doing it. You get 8y cubed. You get minus 32y squared. You get plus 128y, and you get plus 2, 4, 8, 16, 32, 64, 128, 25, 512. And you should be impressed that I did that. Oops. Plus 2y, take away 8, add 7. So x is going to be 8y cubed, take away 32y squared. That guy and that guy gets you 130y. That guy, take away that guy, add that guy, I believe gets you 511. And just to show you, you can get an equation where it's x equals a function of y rather than y equals a function of x. And that's probably harder than anything you're going to see. But you see the process works either way. Are we good? Right. So, next fella. We're going to look at a parametric equation where there's trig functions involved, typically sines and cosines. The other combination that is sometimes possible is secants and tangents, but sines and cosines typically are the ones that you get, right? Now, this one is breaking the rules. We're going to have to deal with trig functions in a different way than we dealt with all the others. All the others, that substitution method we talked about works, right? One way or the other, it'll work. But this is a trig one, so we have to approach it in a different way. I'm going to divide both sides by 3, and in the other one, I'm going to divide both sides by 2. So in a way, I'm trying to get the simplest version of t I can. What I don't do next is I don't pick one of them, probably this one, and try and write it as t equals, because all I'll get is the inverse cosine of x over 3. And trust me, we do not want an answer with inverse anybody, cosine or otherwise. So that's the wrong approach. You won't get an answer that is considered good math, right, in a good format. Right, so don't go there. Just leave it at that. Now we go a totally different route. If I square both sides, x upon 3 squared is x squared over 3 squared, right? If I square both sides here, and now I'm going to rewrite those two relationships, one above the other. I'm going to pause for a minute. I've written them down this way to try and help you see the little trick that you do with trig. Somehow or other, I have got to eliminate the t. I've got to make them go away, turn into a number for sure, but go away for sure. Is there anything you can see that would make those two guys combine in such a way that they would actually disappear as far as t's go? You're saying it, but I can't hear it.
Add.
You add. Now you might say, wait a minute. I'm sticking to my rule. As long as I do it to both sides, it's okay. Can I add both together? It's kind of really that rule. So what do I get? Well, if you add the two pieces on the left-hand side, you get that. And if you add the two pieces on the right-hand side, you get that. And that becomes 1. Some of you may have came across this equation. It's not quite a circle. A circle would be x squared plus y squared, right? Do you know what kind of shape that actually ends up being?
Is it an ellipse?
It's an ellipse. So if you've done I think it's David Fong's class in astronomy, you would probably have seen that equation, right? It's an ellipse. It's the path that objects orbiting the sun, or large objects like that, tend to follow, right? They tend to have elliptical orbits. So let's convince you that that's correct. So I'm going to go back. I'm going to do this guy. And I'm going to type in 3 cosine t. That again. And the other guy I'm going to type in is going to be 2 sine t. Since it's a trig function, or at least this particular trig function, I'm going to go from 0 to 2 pi. Notice that you have to write pi as pi instead of the symbol. So hopefully when I kick out of this, oh, I know what's went wrong. Let me show you. Come back. Now, there's that little planet or asteroid or whatever it is. Watch its pathway as time goes by. It's an ellipse. Do you see it doing an elliptical orbit? Can you see that you could use that as a very simple model for some planet going around a sun? Right. And not only that, if you know enough about ellipses, do you notice that the 3 and the -3 come from here? And the y values go from 2 to -2 and they come from here. So you can actually predict what the ellipse would look like. I think that's kind of cool. Yeah, nice. Ellipse. That's how you do with them. Let's do another one of the trig guys, and then I've got another weird one I want to try out. Almost exactly the same question that we did. I mean, I changed the numbers from a 3 to a 2, but that's all right. So the beginning of this is going to be déjà vu. It's going to be just like the question we finished. Would you agree that you get sine t then is x over t, and y over 2 is cosine t? You happy about what we did in those two situations? Divide by 2. Now, if you square, you get x squared over 4 is sine squared. You get y squared over 4 is cos squared. We all like that, agreed? Now, what am I going to do next? Now think of what we did in the previous question. What do I do next?
Just add them.
Just add them. So you're going to have x squared over 4 plus y squared over 4 equals sine squared plus cos squared, which is 1. Are we good? Now, the last question, there wasn't really much I could do to that would really help it in any way, so I didn't. I can do something to this one that will make it look slightly prettier. What could I do to both sides that would make this a little bit nicer looking?
square root?
Oh no, don't go that way. I know what you're thinking.
Okay.
But don't go that way. Think of multiply. Multiply both sides by 4. And what you get
Oh, okay. I see.
is x squared plus y squared equals 4. Now, do you recognize that guy?
Well, that's just a circle.
Yes. It's a circle radius too. And one of the homework questions gets you to do that. And it says, what do you have? And you will say, I have a circle radius too. Only I think it tells you it's a circle and it just asks for the radius. And I think it's 4. But you know the homework questions keep changing who the number is. So maybe one of them will be a 2. The one I did earlier was a 4. We go with that one. So we're working on kind of parametric equations that have trig functions in them, right? In particular, sines and cosines. So I want to show you another one, which actually I might be able to show you the exact one that I want. Right. So what you're looking at right now, hopefully, is an example of what your homework in 8.4 looks like, right? Is that 8.4 or 8.3? I think I've got the wrong one, actually. Right. Oh, it is 8.4. Okay. So it's down here somewhere. It's got a cosine 2x in it. I'm trying to find the damn thing. Okay, why can't I find you? Okay, Walmart. There is a homework question which I cannot find that looks something like the following. X equals cosine t and y equals the cosine of 2t. And, oh, I don't know, 0.2 pi or something, right? Now you can certainly plug that in. And if you plug this guy into the calculator, you'll end up with a shape that looks something like that. And you just trust me on that. Right. Let's try and eliminate the t's. Well, we got another different situation. We got to adapt. Cosine of 2t is not really helping me any here, because this guy over here has a cosine t in it. I would like this fella here to have cosine t's in it as well, because then I could do a substitution trick. So we're back to a substitution situation, but in a slightly different version. The cosine of 2t is called a double angle. And if you look at the formulas for double angles, there's 3 of them. The cosine of 2t is cos squared t take away sine squared t. You might have seen that guy. But that's not the one I'm going to use. Why? Because it's got a sine squared in it, and I don't want sine squareds. You can also get 1 take away 2 sine squareds. I kind of like that one, except I got a cosine here, so I'm not using that one. There is a third version. Does anybody know the third and final version of the cosine of 2t? Two cos squared t minus 1. Actually, now that I've done that, picture looks like that. No, it doesn't. Darn, it was right the first time. That guy is right. Now, you might say, how's that going to help me? Well, think a minute. If x is cosine t And y is 2 cosine squared t take away 1. Doesn't that make y 2x squared take away 1? So it actually came out really easily once I converted the cosine of 2t into 2 cos squared t minus 1. And that's what the thing looks like, right? Now, in this particular question, they asked you to find the values for x. And you might think, well, how am I going to get them? Well, if you look at this picture, when you graph it, do you know it goes from -1 to 1? So that would be your answer. Do you know you could plug this guy in and this guy in and try and figure out the range, but that probably wouldn't help you so much. But here's another way of doing the answer. The x coordinate is the cosine of t. What's the biggest value for the cosine of t? Or the cosine of any letter of the alphabet? 1, correct. What is the smallest value for the cosine of t?
-1.
Do you see how you can say that since x is cosine, it can't be bigger than 1, it can't be less than -1, so it must be between the two. And that's where that came from. Are we good? Right, so I'm now going to go back in there and we probably get time, depends how long it is, for 1 or 2 more questions. So I'm going to see if I can find a homework question. From section 8.4. I don't know, what are you seeing right now? Anything? Or do you see me zooming in and out of various places to try and make something work? Okay, so parametric, doing a view, open up the window, take out that guy. Right, so I may have to go out and in just so we can see it. So I'm about to re-enter. Boom. Okay, so this is 8.4 parametric equations, right? So here are some pretty standard examples. So I'm just stopping this one for a minute. Can you imagine that what you would do here is you plug that guy in for the x, wouldn't you plug this guy in for the y, and then you'd have a look at the picture and see what you got. And one of these 4 pictures would be the guy you're looking for. Oh, there's a difference between this guy and this guy. Do you notice that the x values are different? So although it has the same shape, you have to look at what the x value ranges is. I believe it would be one of these. Right, let's pick. I don't know. I'm trying to think. Now this is a good one. Yeah, I like this one. Let's pick this one. Now we'll plug it into the software, and one of these 4 pictures ends up being the right one, and whatever it is, you're fine. What I'm going to do is do the elimination situation, and I want to show you a problem with the software. So it's not with us as human beings, it's that the software has issues. So this is a good example of how you might come across this issue. Right, so we're going to do the substitution in the usual way. Both of these can be turned into t equals. They're both equally ugly, but I'm always going to pick the x if I have a choice. So I'm going to divide both sides by 4. We happy with that? And then I'll take the square root of it. No way is that a pretty answer, right? T is square root of 1/4 x. Not very nice looking. That makes it 8 times the square root of 1/4 x cubed. Things are not looking particularly good here, are they? Nice. Can I make this fella here prettier? Well, let's see. Could I do that? Now, if you're thinking, how did that become this? Think about this. Couldn't I break this down into the square root of a quarter x squared times a cube root of a quarter x, right? That fella there, right? So one of these and then it's a bit like me rewriting it as this fella times this fella times this fella, and then grouping these two together to get that. Now you put this fella with that fella and you get 2, you get an x, you get the square root of 1/4 x. And technically speaking, I could make this a little bit better. Couldn't I call this the square root of x over the square root of 4? Now, do you see this had a couple of issues? The first issue is how messy it was to get it into a reasonable looking y equals. That's the first problem. Second problem is that's not the answer the back of the book wants, or the software wants. They were expecting that answer. But this answer is correct. So is this one. They both have plus and minuses. The first one's nice because it's written as y equals. The second one is nice because it doesn't have really ugly square roots and things, right? It's quite a pretty looking relationship between the x's and the y's. So when you are doing some of the eliminations of the t's, can you imagine that you may well get that version and they wanted this version? Now, it wouldn't be a problem if it said yes to both. But some of my students have said it's only saying yes to this one and not saying yes to that one. So you've got to figure out how to make your first attempt look different so that your second attempt will be this. What it's pretty much going to involve is getting rid of square roots and cube roots. So how would I get from this line to that line? What would I do to both sides?
Square them to get rid of the square root.
Right. Now, if you take this guy and you square him, then you take this guy and you square him, which can be thought of as that, which can be thought of as that, which is where x cubed came from. So far, so good? Right. Now I'm going to go back to that same question and see if we can get to the answer that we want with a lot less work. Okay, so that's where we're going. So I am going to look at this fella here, and I'm going to think of him as 1/4 x equals t squared. We can live with that, right? And then I'm going to look at this guy, and I'm going to think of him a little bit, oops, forget that. I'm going to look at this guy and think of him as that guy. Now, what did I do to this guy to get that guy? Can you see
You
what I
squared
did?
the whole thing.
Yeah, 8 8s and t cubed squared. Now, can't the t squared get replaced by this fella? Well, isn't t to the 6 t squared cubed? So do you see what I did there is I basically circumvented the make me t equals and decided to use the t squared equals. But this guy over here wasn't quite the format that would allow a t squared to work. Now, if this had been 8t to the 4 or 8t to the 6, wouldn't it be ready to go? But because it wasn't, I realized that if I squared both sides, I could turn that t cubed into a t to the 6, which was essentially what I wanted, a t squared cubed, which is what t to the 6 is. And then I could do the substitution, a couple of lines of tidying up. Now, if you look at the before and after version, can you see how much more work there was involved when I went the t equals route to get to the format that they wanted? Now, in a test situation, it doesn't matter so much. What I mean by that is, if you get to this answer and you write it down in the test, I am happy with that and I will give you the full points. Of course, when you do the test, it will say 0 because it was wanting this answer. But when you send your work in, I'll look at it and I'll give you the points. Unfortunately, in the homework world, you may have this answer, but it wants that answer. So if your answer, although it's totally valid, doesn't work, you're going to have to figure out how to turn it into version 2 so you can get your homework point. If you run out of shots in your homework and you didn't change it into the nice pretty form, right? Well, the other form rather than just pretty form. Shoot me an email telling me what you had. If it's correct, I will just go back and give you the point.